Hello viewers, in this video lecture we are going to discuss the orientation and reactivity of monosubstituted benzene. In the last few classes we discussed some aromatic electrophilic substitution reactions like nitration of benzene, halogenation of benzene, sulfonation, Friedel-Crafts alkylation and acylation reactions. These all reactions we studied on unsubstituted benzene, that is simple benzene, there is no substitution. Okay. In that case, what happened? See, this is a simple electrophile, that E plus, that the benzene will attack this any electrophile and it will give this, yeah, the electrophile will be substituted in any of the benzene carbon. If the electrophile substitute any of the benzene carbon, the product will be remain same, any carbon. So there won't be any problem. Now let us take the monosubstituted benzene. Suppose some group is already substituted on the benzene. If we do the aromatic electrophilic substitution reaction, then what will happen? Where the incoming group will come and substitute. So that only we are going to discuss. Okay. Now let me understand clearly about orientation. What is called orientation? Orientation is, listen carefully. So this here I took the monosubstituted benzene like this. So here the Z is one functional group or some other group has been substituted, and here some electrophile is going to react, and where the electrophile is going to substitute. That means that already the existing group that will determine the incoming that electrophile's position on the benzene ring. Okay, so this is called as orientation. Now I numbered here that Z, the group connected on the benzene ring, is the first one. Okay, I mentioned first. You see here there are three different positions, 2, 3, 4. Okay, so that electrophile may be substituted here. So if it is substituted on the second position, then we will call it is an ortho substitution. If it is at the third position, then it will be called as a meta. If it is at the fourth position, then it will be called as para substitution. That is the relation between that Z and that electrophile. Okay, 1 and 2 ortho, 1 and 3 meta, 1 and 4 is called para position. So that Z group is deciding the incoming electrophile's position on the benzene ring. Now how the Z groups will be classified? Now here the Z groups will be classified as two types. One is ortho para directing groups and another is a meta directing groups. If it is like alkyl, aryl, these are the groups, hydroxy or this ester, that amino groups and amido like thioether, halogens, these all are come under the ortho para directing. And these are the meta directing groups, nitro, cyano, this is tri, halo, this methyl group, CX3, X is a halogen, this is the NR3, this is a quaternary ammonium, this is sulfonic acid SO3H, and this is sulfonyl group, any sulfonyl group, and all carbonyl group, that is C double bond O. These all are meta directing groups. We will discuss why these groups are ortho para directing and why these groups are meta directing, that we will see in forthcoming classes. Now how this group will direct so to the incoming how these groups will decide the incoming electrophile's position. Okay, so this groups means we should accordingly substitute the electrophile according to the ortho para director means ortho and para position, meta director means meta position. Okay, let me see some example. I take like this. You take this benzene and any ortho para director like this, something OCH3. So this is a ortho para director. If you do the bromination, this halogenation, the bromine in the presence of FeBr3. So since this is a OCH3 is an ortho para director, that bromine will be substituted at both ortho and para. Okay, like this. Ortho is one product plus para is one product. Okay, because why this bromine is substituted in ortho and para? Because this OCH3 is an ortho para director. Okay, so that's the reason we are getting the mixture of ortho product and para product. Please always remember that the para product is always major. That also we will discuss in the forthcoming classes. Here we should understand what type of groups, ortho para directors and meta directors. Let us take one meta director, like any carbonyl compound like this, carboxylic acid or aldehyde, whatever it is. If you do nitration, HNO3, H2SO4, the nitro group will substitute at meta position. Okay, so why? Because this is carbonyl group is a meta director, that's why we are getting that nitro group at meta position. Okay, so this is how the existing group will decide the incoming electrophile's position and the monosubstituted benzene. Okay, so these are all about the orientation. Next we will discuss about the reactivity. Okay, now in the case of reactivity, here some groups will activate the benzene, and that groups will facilitate the aromatic electrophilic reaction very faster. Certain groups will reduce the rate of reactions. As we discussed earlier, the ortho para directing groups always activating groups. That means it will faster the electrophilic substitution reaction. It will give fast. Meta directing groups, these are called as deactivating groups, and these groups will slow down the aromatic electrophilic substitution reaction. Here I will show you some example. The same example you can take it here. So whatever we discuss, okay, let me take this one. Like this. Now CH3 will take. Okay, so CH3 is an ortho para director and this is an activating group. If you do the halogenation, and this reaction will go faster. Okay, and this will give both ortho and para, but this reaction will be a faster one. Why? Because these are activating group. It will increase the electron density and push the electron density towards the benzene ring system. That's why this will be very faster. This reaction is fast. Now the same bromination, if you take this nitro substituent, okay, and this is a meta directing group, and if you do this reaction we will get the meta product, but the rate of reaction will be slow. The reason is these are the nitro groups are electron withdrawing group, and it will withdraw the electron density from the benzene ring, okay, like this. It will withdraw the electron density from the benzene ring. As a result, it will slow down the reaction. That's why meta directing groups will slow down the reaction. Which one? Aromatic electrophilic substitution reaction. Ortho para directing groups, it will increase the rate of aromatic electrophilic substitution reaction. That's all about the orientation and the reactivity of monosubstituted benzene. I hope you understand this lecture. If you feel this is useful, kindly subscribe and share this video lecture. Thank you.